Well, let's look at a few examples of some very interesting phenomena that people have witnessed. So, if we want to talk now about getting away from stuff you have to look at under the microscope to stuff that you can actually see happening in the sky. So, I love to go back into some of the old journals because the old journals were really one of the things that they like to do was publish these accounts. I mean, you look at the old uh, astronomy journals and things, they're filled with these accounts of people, witnessing things. This is from 18. What I'm going to read to you parts of now is from 1899, Popular Astronomy, and this is on the night of August 7th, 1899, while observing the comet Temple. Now let's see. I have a list of comets here. Here we go. All right, so this is selected meteor streams uh, with data, and so this is not all the meteor streams, of course, but this is some of the ones that I think are the most interesting and important. Name of the stream down on the left, and then the comet that they're associated with. So you have the quadrantids and their date of peak, January 4th, the Lyrids, April 22nd, Eta Aquarids, early May, Perseids peak August 12th to 15th, the Leonids peak November 17th, Draconids on October 7th to 9th, Geminids, and the cometary source. Notice the Leonids are associated with Temple Tuttle. Now, this doesn't mean that we can't see meteors that are part of these particular meteor streams any other time of year except these, because there is a random component to this. But generally, we're going to usually, if you see a meteor on April 22nd, it's probably going to be part of the Lyrid stream, which ultimately is associated with Comet Thatcher. And then we'll go back to what I was getting at. So on the night of August 7th, 1899, while observing the comet Temple 1899C, I was startled by a vivid illumination of the floor, as if by a flash of lightning. Glancing up through the dome slit, so this is an astronomer. The dome slit is the slit in the dome, of an astronomical observatory. Okay. Glancing up through the dome slit, I saw a portion of the meteoric trail, which was very bright and narrow and the color of Sirius. 5 minutes after this apparition, I unexpectedly heard a loud rumbling, which sounded as if a couple of distant cannons had been fired in quick succession. And Mr. John Nichols, Jr. of Golden, Colorado, sent me the following information. About 20 minutes after 1 o'clock, this would have been in the morning, Mr. J.D. Williams of this place and myself were chatting on the street, when suddenly the whole place became as light as day, and we heard a loud rushing noise. Looking up, we beheld what seemed to be a big ball of fire rush through the heavens from the east to the west and bursting way in the west. In its first onward rush through the sky, it seemed to separate and leave behind it a kind of trail of fire. When the ball of fire rushed through the sky, it left behind a greenish tinge. And then also from Popular Astronomy, published in 1912. This was a meteor sighting on May 30th, 1911. About 7 o'clock p.m., the 30th of last May, I was standing in my yard facing west when a brilliant meteor caught my eye, which I will try to describe, though no words can carry an adequate picture of it to one who did not see it. It consisted distinctly of a head or nucleus and a long tail. The head, about 3 or 4 times the apparent diameter of the sun, showed a mass of intensely brilliant streaks and patches of fire, much like the effect of a bursting skyrocket. This stately meteoric train, steadily moving with perhaps 1/4 the annular velocity of a shooting star, spurning both earth and sky, and aimed at some unknown faraway point in space, and never to be repeated in the experience of one lifetime, will remain as long as earthly memory survives, the most striking emblem of the majestic. I would have liked to have seen that. Okay, here's one from an account from was published in May of 1916, but it occurred on, let's see, this was a cowboy out on the range, I guess. He was, well, at least it was a guy out on the horse. He says, I wish to report an observation of mine of a brilliant fireball about 7 p.m. 1916, April 1st. It was one of the largest that I ever saw, was moving very slowly and seemed to leave portions of its substance in its trail in the form of sparks. It came from an easterly direction and moved almost due west. It was moving so slowly that I could easily see its nucleus. When I first saw it, its motion was such that I unconsciously leaned over in my saddle for fear of it striking me. I heard no explosions nor any other sound, although I listened closely. I believe that when it vanished, it was less than a mile from my position. Remember how we talked about this kind of the illusionary aspect of this phenomena, that people think that it's so close to them? That thing was probably 20 miles up in the atmosphere, but he leans over on his horse because he thinks that it might strike him. And this was regarding two sets of fireball sightings, one November 15th and one December 29th, 1925. In the morning papers of November 16th, 1925, the fall of a remarkable bright daylight meteor somewhere in New England was reported. When the observers' stations were plotted on a map of New England, the points were dense about Boston and thinned out from there in all directions. The object itself was described as a glowing, glaring ball of golden fire, which dragged a bright tail after it. It plunged sharply downward, east to north, and many observers said that it either vanished or exploded above the horizon in eastern Massachusetts. Many, in widely separated places, were confident that they saw it drop to earth within a few miles or a few rods. So this is over and over again. Again, part of that sort of the perspective thing of this. They're thinking, oh, it just fell over the next hill. But it actually might have been 100 miles away. And I've seen enough fireballs that you can kind of see how that is, And I've told you about my grandfather when he was a boy in Sweden, seeing the thing that he described to me. And he told me this story a bunch. That's why I still remember it. But saw something like a fiery beam come over his head and then fall in. I think he said he was fishing, and it was winter, if I'm recalling right. So he might have had a hole in the ice, or I don't remember if it was when. I don't remember the season. The story was too long ago. But he said it was like a flaming beam, and that's the word he used. He described it, came over his head and then plunged into the lake. Now, I don't know if it plunged into the lake or, it might have. In Sweden, there's some pretty big lakes. So, I mean, if it had been a mile or 2 miles across, he might have thought it plunged into the lake, but it didn't really. But I remember him telling me that story because he never got tired of telling that story, because that was undoubtedly his one big eyewitness experience of some kind of a cosmic phenomena. And later on, as I read accounts, and I remember as a kid, I was like so puzzled, what would that be? What in the world did you see? And of course, he didn't really know what it was. But in retrospect, having read many, many, many eyewitness accounts now, I go, well, that's pretty certain that's what he saw was a meteor. Another account from January 1928, also Popular Astronomy, flocks of fireballs. Last August, someone reported in local newspapers sights of one of these large meteors lasting long enough to make a streak of fire across most of the sky. A published note by Dr. Fisher asking for more information brought 249 replies from persons who thought they had seen this same ball of fire. The truth, however, was even more interesting. A study of these reports convinced Dr. Fisher that what his informants had seen was really a flock of these celestial visitors. Not one of them. Meteors seen on October 16th are disclosed by similar public reports to have consisted of at least 12 separate objects, all of which must have been traveling through space in a more or less close-packed group, and all of which encountered the Earth and burned up in its atmosphere at approximately the same instance. It is not impossible that these observations introduce a new concept in astronomy, the concept of what might be called minor comets. Single meteors are already well known and are believed to be tiny bits of iron or stone, probably no larger than a small nut, which hit the atmosphere, burn up, and form shooting stars. Comets are believed to consist of somewhat similar materials, but with the particles gathered together in flocks to make the comet's head or nucleus. It is probable that some of the particles in these cometary heads are much larger than those that form ordinary shooting stars. The flocks of fireballs, which Dr. Fisher's observations disclose, may be intermediate between the single meteors and the groups of meteoric particles numerous enough to be visible as comets. And here's another interesting, and of course, this is what I say, 1926 for this. So, yeah, obviously, our understanding of a cometary, the structure of a cometary nucleus, has come a long way since then. But what we still have is a model of a very loose aggregate that can disaggregate quite readily and produce multiple objects, right, from a single cometary nucleus. And this is something that we'll explore in more in depth in the future, because there's a lot of this kind of stuff, which at first glance wouldn't seem to make a rational connection, but who knows? So this is from September 1928. So there was an unusually brilliant meteor. It was preceded by a small tornado, hail, and rainstorms in South Georgia. Oh, the paper was in Tennessee, but the event was in South Georgia. Preceded by a small tornado, hail, and rainstorms in South Georgia, a fiery meteor described as larger than a house flashed through the skies from Waycross, Georgia to Charleston, South Carolina about midnight last night, to end in an explosion that shook buildings and awakened hundreds of people in towns along the route. The celestial phenomena was visible over an area approximately 400 miles square, 200 miles on either side of the flash. People attributed shocks felt in their homes to an earthquake. But United States Weather Bureau officials said that there had been no earth disturbance in the southern states and that the tremor was caused by the explosion of the meteor in all probability. But in the aftermath of Tunguska and those accounts, it certainly does seem like there is a terrestrial component. Because remember the description of people feeling, shock waves passing into ground, the sound, the sonic effects of something passing under the ground that they described like many freight trains all passing at once. And there was a 5.5 actually registered earthquake. So it's very possible that this explosion actually did produce tremors that were felt. Now, we also, and we didn't get into it much, but we touched upon the correlation between the Tunguska event and a response in the Earth's geomagnetic field, which would be something that would certainly be worth exploring in more greater detail. But the thing that intrigues me here is this association with some unusual weather. And this is something else that we find again showing up in a lot of accounts, even going back to ancient accounts of cosmic and celestial phenomena and its association with unusual weather. Now, could there be an interlink? Could there be some events like this, Earth's geomagnetic field, and what's going on with the atmosphere? I would not rule that out.
Yeah, it said it was a hailstorm and what did they say? A tornado?
A tornado, hail, and rainstorms.
Okay, but it must have been after that, right? I mean, you wouldn't see a comp. Yeah, okay.
Right. In this case, I mean, who knows? Maybe it's purely coincidence. But there are quite a few accounts where you will see these associations between something in the heaven and something on the earth over and over again. There's an earthquake. This was common. Unusual weather, that seems to be common as well. So that's something that we'll look into. I think it's worth looking in greater detail. Now we're going to jump forward to 1993, the Journal of Geophysical Research. I think they're probably astronomers, Robert T. Dodd, Stephen F. Wolf, and Michael E. Lipschutz, who wrote this article about what the H chondrite stream. Chondrites are a type of meteor body Until recently, there seemed to be little point in seeking order in the distribution of meteorite falls. On one hand, it appeared certain that the process that bring meteorites to the Earth, namely impact and gravitational perturbation, would scatter them, destroying all dynamic evidence for their sources. On the other hand, there was no astronomical evidence that either meteoroids or their source objects approach the Earth in order. However, the situation has changed dramatically in recent years with the observations of streams of radar meteors of asteroidal origin, dense fireballs, and Amor asteroids. Additional evidence of order in the distribution of objects near the Earth comes from analysis of lunar seismic records and simultaneous, very low frequency radio propagation anomalies in the Earth's atmosphere. So we might have some connection possibly there. That might be pointing. What he's getting at here is they're going from a model of just pure randomness with no order to it, no structure to the pattern of impacts, to this idea, no, that there may be an ordered structure to it. There may, in fact, be a periodicity. We have demonstrated that the Earth encountered a significant concentration of falls, meteorite falls, in May between 1855 and 1895. More recent May falls may also belong to the cluster, but we cannot now either prove or disprove this. The only plausible explanation for a concentration of falls that persists for at least 40 years is an encounter with a stream of meteoroids. In view of Halliday et al.'s 1990 observation that some contemporary fireball-producing meteoroids approach the Earth in streams, it is not surprising to find that historic meteorite falls did so as well. That said, many aspects of the stream components reported here are more or less unexpected, right? Because what we're seeing is the shift now from a random model of these encounters to a much more structured model where there might be a periodicity. And rather than isolated random encounters with meteorites, there may now be what they're talking about here, streams of meteors. The identification of meteorites that traveled together in space raises many questions and opens new windows for research. Among old and vexing issues on which studies of meteorite streams may shed light are the nature, number, and structures of meteorite parent bodies, the meaning of exposure ages for fragmentation histories of meteorite source objects, and the history, that is, the constancy or inconstancy of the meteoroid flux. Clearly, the existence of streams of Earth-approaching meteoroids also has implications for calculations of the likelihood of life-threatening impacts on our planet. For such studies can no longer assume that the meteoroid flux is random. Now, I think this is critically important shift in our understanding of the nature of the near-Earth environment. This shifting to idea that there may be clustered events, there may be streams that would increase the probabilities of encounters above and beyond the background random count, maybe by orders of magnitude. At about 9:30 p.m. on the 9th of February, 1913, there suddenly appeared in the northwestern sky a fiery red body, which quickly grew larger as it came nearer, and which was then seen to be followed by a long tail. Some observers said the tail seemed like the glare from the open door of a furnace. To others, it was like the illumination from a searchlight. To others, like the stream of sparks blown away from a burning chimney by a strong wind. The body moved forward on a perfectly horizontal path with peculiar, majestic, dignified deliberation. And continuing its course, it moved on to the southeast, where it disappeared in the distance. But before the astonishment aroused by this first meteor had subsided, other bodies were seen coming from the northwest, emerging from precisely the same place as the first one. Onward they moved at the same deliberate pace in twos and threes, with tails streaming behind. They all traversed the same path and headed for the same point in the southeast. Gradually, the bodies became smaller until the last ones were but red sparks, some of which were snuffed out before they reached their destination. As to the number of bodies, there was a great diversity of statement. The usual estimate was from 15 to 20, but others said 60 to 100, and even others said that there were thousands. The entire time occupied by the display was about 3 minutes. Just as the bodies were vanishing, there was heard in many places a rumbling sound like thunder. The stretch of country over which the display was seen is unprecedented. In the present case, persons dwelling 2,500 miles apart saw the same bodies. Moreover, the descriptions furnished by observers in Bermuda, in Ontario, and in Saskatchewan do not materially differ. Observations of the size of the bodies were very discordant, but there is sufficient evidence to show that they were of considerable size. Several observers considered the leading body to have a diameter equal to that of the full moon, or nearly so. One observer estimated that of the full moon, and another at 1/15 of the moon's diameter. The last estimate gives a real diameter of 123 feet. The largest bodies were at least 100 feet in diameter. The tail of the largest meteor is estimated to have been 39 miles long. Let's ponder this for a minute. And as we're doing it, let's take a look at a painting that was done at the time, or shortly thereafter, by Gustav Hahn of the Great Meteor Procession of 1913. So now, notice if from the observers, and of course, obviously, the closer you are, the larger it's going to appear. But from the various perspectives of the observers, you've got estimates from 1/15, what did it say, 1/15 of the diameter of the moon, to half the full moon, to a diameter equal to the full moon. So then it's estimated that there were, perhaps dozens of these objects, and that many of them were more than 100 feet in diameter. Well, that puts those objects in the Tunguska size range, doesn't it? What was Chelyabinsk? 50, 60 feet in diameter. Tunguska, 140 to 150. So this procession may have, we don't know, but it may have contained or included multiple objects the size of Tunguska, or maybe even larger. Well, that has some rather interesting implications, doesn't it? Here's a map that was drawn at the time. This was done by an astronomer who took all of the eyewitness accounts and plotted the path. And this is what he came up with. You can see here, it's coming down. It's difficult to see. It's coming down here over Lake Superior. See up here, it's first being observed up in Saskatchewan. And then it comes down. It was observed in Manitoba. It was observed in the Dakotas. You can see that the pathway leads it over northern Minnesota, over Lake Superior. Then it's coming down here and comes very close to Montreal. And then look here. Dead on, passes right over New York. Now, think about this, 1913. This object undoubtedly came in and became almost like a sublunar satellite of the Earth for a little while. It finally disappeared down somewhere over the ocean. It was witnessed by sailors out at sea. So, this is how the pathway of 2,500 miles was calculated.
Yeah, it says Saskatchewan to Bermuda.
Saskatchewan to Bermuda, but it was actually a thing seen beyond Bermuda.
Ah.
By these sailors at sea. So
this would be a really low angle. Is that what you're saying? It would actually been close to being in orbit?
Yes, that's what I'm saying.
Okay.
But imagine if the angle had been ever so slightly steeper.
Yeah.
Now what have you got? 1913, over the Great Lakes region, over New England, multiple Tunguska-sized events.
Yeah.
Directly over New York City. You think 20th century history might have been somewhat altered if that had actually happened?
A little different.
A little different, I would say, yes. So this is a very interesting case study right here. And it opens the door to some rather unnerving possibilities.
Do you think that was I know nobody has the answer to this, but do you think that was the main object, or was this just pieces of something?
Oh, I think it was probably an object that came in
fragmented
and fragmented. Or maybe was even fragmenting before it entered the Earth. Remember, Shoemaker-Levy 9, right?
Because those look like clusters in that painting. He was showing clusters of objects right next to each other.
Yeah. I think I have a Shoemaker-Levy 9 right here. And here we go. I'm thinking this kind of probably gives us the closest example of what it might have been, as a mini version of this right here. And of course, this was originally one object that became 21 separate objects. And if it hadn't collided with Jupiter on this particular next passage, 21 objects might have become hundreds of smaller objects. Now, I think a lot of these objects were estimated in the kilometer size range. So if that being the case, then any one of these objects could perhaps supply hundreds of thousands of Tunguska-sized objects. So see, that's what I think is what we really need to be looking at in terms of planetary defense. Because, the dinosaur killers are very real. A 6-mile asteroid slamming into the Earth, mass mortality, extinction level event, planetary extinction level event. Obviously, a planetary extinction level event is going to wipe out civilization completely. Any survivors of such an event are going to be living a Stone Age existence, because there's going to be no such thing anymore as a supply chain. There's not going to be any radio communications with anyone. There's not going to be any satellite. All of that's gone, right? But we're talking about, something that's very not impossible, but very improbable. But what is far more probable is when we get down to a Tunguska scale event, which, were it to happen today over a populated area, would be a hell of a significant event. Because look, if one of these objects that we just talked about in the precession of 1913 came in and it was the size of Tunguska and it detonated above New York, you're talking instantly 1 million people are dead, and there would be no catastrophe. You could have a world war for 5 years and get 1 million people dead, but you're not going to get 1 million people dead in a matter of a minute or a few minutes from any event in recent history. But a Tunguska event over a densely populated area of the globe happening now would instantly produce hundreds of thousands, if not millions of deaths and 3 or 4 times that many injuries. So even a small cosmic event would be very significant in terms of its consequences.